Welcome to this module. In this module, we are going to take a look at a half-cut or a half-cell solar panel. We made mention of the PERC monocrystalline solar panels, that there are improvements from the conventional monocrystalline panels. So if you see a panel that you are having the probe at the middle of the solar panel and you have this demarcation, there are half-cut solar panels. So your half-cut solar panels are improvements from conventional monocrystalline solar panels. In half-cut solar panels, the solar cells are cut into half of its original size. You can see it on the picture here. So a half-cut solar panel is normally made up of two parts. We are going to expatiate on that, why we have the two parts and how the connections are done. We said before now that the efficiency of the PERC panels are higher than that of the conventional solar panels. So performance wise, half-cut cells will help increase cell efficiency by a percentage. Then you have to know that the half-cut solar panels are more physically durable than their traditional counterparts. If you are talking of durability, the half-cut solar panels are more durable than their conventional counterpart because the sizes of the solar cells are reduced. The sizes of the solar cells are reduced. There are half of the normal conventional monocrystalline solar panels. And when the sizes are reduced, there are more resistance to cracking. That means there are resistance wise, there are more resistance to cracking than the conventional monocrystalline solar panels. And you know that when the solar cells are smaller, they tend to the mechanical stress on each of the solar cell here will be reduced. They will be reduced and they will give a higher output. We are going to look at how the connection here is done and how that leads to a better output that we are having with the PERC or the half-cut solar panels. If you look at diagrammatically, if you look at this electrical connection, you are having two sections. You can see here that you are having two sections with 60 cells. This is the first half. If you count the number of cells here, you have like 60 cells. Each of the cell here is 0.5 volts. And if you look at the second half here, you are equally having 60 cells. What really happened is the first half here, they are connecting the solar cells here in series. And you know, when solar cells are connected in series, the voltage will definitely increase. And the same thing happened to this second half. They connect the cells here in series. After connecting the first half here in series, you have um, 30 volts, and the second half here is also connected in series, and you equally have um, 30 volts. After that, that means we have gotten 30 volts. After that, the first and the second half are connected in parallel. And when you connect solar cells in parallel, the voltage will remain the same, whereas the current will increase. When the current increase, that means when you multiply the resultant, the final increase in the current and the voltage, that is what happened. But in a conventional solar cells, they are all connected in series. But when we are talking about the half cell solar panels, the solar cells are half cut, and it has two sections, the first section and the second section. The first section they are connected in series, the second sections are connected in series. After that, the two sections are connected in parallel to increase the power output of the solar panel. And if you look at it here, that means we are having about 120 cells when you are talking about this, and you are having about 550 watt solar panel. What is the advantage of a half cut solar panel as compared to the conventional solar panel that we have? The first advantage is that the panel will have higher output. From the illustration that was before you, you can see that it will always have a higher output. There is a 5 to 20% lower space requirement. That means if you are using the conventional monocrystalline solar panel, you might tend to use a bigger space, a bigger roof size, or if you are using stanchion, you might end up constructing a larger stanchion. But when you are using a half-cut solar cell, that the efficiency is increased. It tends to lower the space requirement. There is durability. We have already said that there are more resistance to cracking because the solar cells are reduced, so they are more durable. And even we know that when you are talking about a solar panel, the temperature that the solar panel is subjected to most times affects the productivity of the solar panel. So half-cut solar panels are more durable when compared with the conventional solar panel. Thank you.